Okay, stats class. We stopped notes yesterday at about this point right here. Let me see, this point right here. And I'm not on my normal dot camera that I'm writing on because I don't have a dot camera at home. So I'm writing on my, I don't know, notebook, whatever. So my handwriting gets to be a little crazy at times on here. So bear with me. Um, we computed the standard deviation, and I'm not completely 100% sure what these were, but I think this was something like 16.48. You can change that number if I'm wrong, but I think the bottom number was 16.48. I'm going to use that standard deviation to kind of lead us into the next example here. So um, basically we're talking about data speeds and we're talking about how they deviate from one another. Okay, so a large standard deviation means that they're kind of all spread out, like the data speeds for this internet or Verizon data speeds. They're kind of all over the place. The larger that number gets, okay? The smaller that number gets means you're pretty well consistent. Like Verizon is doing a good job of getting support and speed to just about everybody. They're doing a good job. So they want this standard deviation to be as small as possible, where everybody's consistent. Now, just because the standard deviation is as small as possible doesn't necessarily always mean that it's good. For example, you can be consistently sucky, right? So Verizon, even though they're consistent, maybe they're not consistently fast data speeds, maybe they're consistently slow data speeds. So they want this number to be as small as possible, yes, but they also want to be in a good data speed range. So I should correct myself on that, all right? Now, when we're looking at significant high values and significant low values, what this means here is we look at the average. Oh, geez, I don't remember what the average was. X bar, shoot, X bar was, I can't remember, 20 something, 20 something, 20 something. We're going to say, you're going to have to change this. We're going to say, I can't remember what it was. How can I not remember? 24 something? Screaming at me. Maybe I'll osmosis it through this video. We'll say 24.1. Maybe that's not right, but we'll say it is, okay? X bar, let's say the average is 24.1. So we're going to put 24.1 here. We can say that a significantly high Verizon data, like somebody is doing real good, is 2 standard deviations above that. So 2 standard deviations would be 32.96, because I would double this, times 2. 2 standard deviations above that. So what I would do is to find significantly high data speeds is I would add 2 standard deviations, or 32.96, I would add that to 24.1. So the cutoff range for significantly high data values would be at, let me see if I can add in my head, 57.06. 57.06 would be considered a high data speed. So anything above that would be considered high. Now, none of these are above that, so we have sucky internet and sucky data speeds. So let's see if anybody is below that, like this 14.1. I don't think so. 24.1, if we subtract 32.96, that gets us into the negatives, which really isn't accurate because you can't have a negative data speed, but we're going to pretend that you can. 8.86, negative 8.86 is considered a significantly low value. So that's just because the average is low for data speeds, is the reason why we hit into the negatives. So don't take that, don't put too much emphasis on the fact that that's negative, because you can't really have a negative data speed, but it's just because our average is so low in the first place. So, and maybe that's not the right average in the first place. I'm not really sure. I can't remember what it was to begin with. So change those numbers according to what that average should be. But significantly high values would be data speeds that are above 57.06. Low data speeds would be anything below 8.86. That's 2 standard deviations above or below the average, all right? Now, if you are lazy and don't want to calculate the standard deviation using one of these 2 methods that we did above here yesterday, okay, because those were kind of long methods, what we can do is we can estimate the standard deviation by taking the range of the data values and just dividing by 4. This is an estimation. They call this the range rule of thumb. So they say use the range rule of thumb to estimate what the standard deviation is. This is not accurate 100%, but it gives you a pretty good idea, all right? So they want us to, I'm going to bump down to example 5 and then we'll come back up to example 6. So they want to use this range rule of thumb to estimate what the standard deviation should be for this guy. So we have 50 Verizon data speeds listed in dataset 32, whatever, we don't care. They don't list out all of them, but they do say that the minimum data speed is 0.8. Oh my God. They're living in the boonies. And the maximum data speed is 77.8. That is considered a significantly high value because it's above 57.06. So they're doing good. They're living well. So our range would then be the highest number. Range, if you remember, range equals high minus low. So we would take 77.8 minus 0.8, and that is 77 exactly. And what we would do is to find the approximate standard deviation using the range rule of thumb, we would divide that by 4. 77 divided by 4, I feel like one of you guys because I'm sitting here on my phone calculator, which is not a good calculator, by the way. I hate this thing. 19.25 is approximately the standard deviation. Now, these data speeds are based off of the same information that we had from above, except these is a sample of 50 rather than a sample of 5 that we did up here. So we got 19.25. They got 16.48. Well, the other way around. We got 16.48. They got 19.25 if you use the range rule of thumb. So it's a little bit off, but maybe that has to do with the fact that we had more numbers here. So maybe it is closer to 19.25. We don't know. But this is just a way of estimating it. If we want to be kind of lazy, all right? So there's that. Using the 50, so we're going to go back up to here. We're using the 50 Verizon data speeds listed in dataset 32. The mean is 17.6 and the standard deviation is 16.02. We want to use the range rule of thumb to find the limits separating the values that are significantly low and significantly high. So we have our, I kind of do a number line here. Okay, so this is the average, which is mean, 17.60, that's the average, okay? And I want to know high values and I want to know low values, okay? If the standard deviation is 16.02, standard deviation, high values would be 2 standard deviations above that and low values would be 2 standard deviations below that. So I'm going to take this number and I'm going to multiply by 2. 16.02 times 2 is 32.04. So what I'm going to do is to find this high value, I'm going to add that to 17.6, and to find the low value, I'm going to subtract that. So if I add, let's see, I can do this in my head maybe, 49.64, that's significantly high. So anything above 49.64 is considered significantly high. Now, our low significant value is going to go into the negatives again because 17.60 minus 32.04 is going to be negative 14.44. So that is considered to be a really low, a significantly low data speed. All right, and your data speed again can't go into the negatives, but it's just because our average is so low in the first place. So yes, Verizon can come back to you and say nobody is significantly low because you would have to be in the negatives before you're significantly low. So Verizon overall just kind of stinks in general because their average is really low. There we go. Next page. All right, population standard deviation. Don't worry about that for right now. Don't cross it out, but I'm going to cross it out because we're not going to talk about it right now. We're going to talk about it later, okay, when I come back. So let's do this. Let's go down here. Let's talk about part 2. Introduces the empirical rule. I will give you a laminated version of this empirical rule, and we talked about this yesterday. We said that it's not 66%, it's 68%. I was wrong. 68% are going to live within 1 standard deviation of the average. So let me do this for you. We're going to say the average test score for your class is an 85, and the standard deviation is 5. So what this means is that 85 is living here in the middle. Right? And what I do is that I add 5 percentage points to make 90, and I subtract 5 percentage points to make an 80. So that means that if I survey all of you guys in class, 68% of you live within 80 and 90%. Okay? So 68% of you scored between an 80 and a 90. Now, if I do that process again, and I add 5 points, which would be like your x bar plus 2s. You see where that says it underneath here? X bar plus 2s, that would be a 95. X bar plus 3s would be 100%. Okay? X bar minus 2s would be a 75, and an x bar minus 3s would be a 70. Okay? So we have this going on here. We're subtracting 1 standard deviation, subtracting 2 standard deviations, subtracting 3 standard deviations, or adding 1, adding 2, adding 3. So 68% lives between an 80 and a 90. This range right here, 80 and a 90, that's 68%. Now, 95% is going to live between 2 standard deviations. So this range from a 75 to a 95, I can say that 95% of my students would have scored between a 75 and a 95 on their test given this information. And then the third standard deviation says that 99.7% of my students are going to live between 70 and 100%, okay? So there's still that 0.3% chance, the J-schoolas that are out over here that are scoring 50% or lower, right? Or maybe even 60% or whatever. So, or maybe we'll give Jace the benefit of the doubt. Maybe he got bonus and he scored 105. I don't know, but probably over here, probably in this range, right? We don't want to give Jace too much credit. So 99.7% typically, according to the empirical rule, live within 3 standard deviations on either side of the mean. If the mean is 85, I add 3 standard deviations, that's 100. I subtract 3 standard deviations, that's 70. And 99.7% are going to live in that range, okay? So the empirical rule. Let's figure out what this says. IQ scores have a bell-shaped distribution. Bell-shaped distribution. Let's draw a bell shape. Do the best you can. Here's my bell. Oh my goodness. Oh, that wasn't too bad. That wasn't too bad. Bell-shaped distribution, and the mean here in the middle, average always goes in the middle, is 100. Okay. Standard deviation is 15. I'm going to write these off to the side over here just so that I don't forget them. X bar is 100. That's what mean means. And standard deviation, which we denote as S, is 15. What percentage of IQ scores are between a 70 and a 130? Okay, so what I'm going to do here is I'm going to add 15, which is 115. I'm going to add 15 again, which is 130. And I'm going to add 15 again, which is 145. Okay, this is like the, I'm going to do here, this is like the +1, woo, extend page, I didn't mean to do that, but that's okay, I like it. +1, this is +2 standard deviations, this is +3 standard deviations, okay? Now if I do the other side, if I subtract them, 110 minus 15 is 85. We're getting some real smart people over here on this end. 85 subtracting another 15 would be 70, and subtracting another 15 would be 55. Ouch. Ouch, ouch. Okay, so this would be like the -1 station. This would be like the -2 station, -3 station. So I'm subtracting 1 standard deviation from 100, I'm subtracting 2 standard deviations from 100, subtracting 3 standard deviations from 100, right? Okay, so there's where that lies. We are interested in finding this range right here, from 70 to 130, okay? So both of those are 2 standard deviations on either side of the mean. So I'm looking at this region here, and according to the empirical rule, 2 standard deviations this way and 2 standard deviations this way would be this range right here, which is represented as 95%. So we would say that 95% of people living out in the world have an IQ score that's between a 70 and a 130, okay? You will have 5% of people either here or here, where you have some really low people and you have some really high people that are the genius range, okay? So not everyone lives there, but 95% of people are going to live between 70 and 130, okay? All right, let's see what we got next. Last thing, Chebyshev's theorem, okay? So Chebyshev's theorem is basically another theory that exists as opposed to the empirical rule. So empirical rule versus Chebyshev's theorem. Okay, Chebyshev's theorem has a formula, 1 minus 1 over k squared. Okay, where they're talking about k being the number of standard deviations. So this is what Chebyshev's theorem says. If I draw a bell curve, he does not agree with the empirical rule. The empirical rule said that 68% were within one standard deviation. He does not agree with that. So he says x bar lives here. And if my standard deviation is 1 away from x bar, meaning 1 on the plus side, 1 on the minus side, if we're 1 on the plus side, 1 on the minus side, you use this formula to determine what percentage that is. So we would do, if we're doing 1 on either side, that would be, I'm going to write up here, 1 over, no, wrong. Let me delete. Okay, here we go. 1 minus 1 over k squared. And k, in this case, would be 1 standard deviation. Actually, you know what? This only works for numbers that are bigger than 2. So we're going to start with 2. Ugh, he doesn't have a rule for number 1. And then we square that. Okay, so 1 minus 1 over 2 squared. We can't use 1 because this formula doesn't work for 1. All right, so we do 1 minus 1 over 2 squared, which is 1 minus 1/4. Okay, 1 minus 1/4 is 3/4. So he is saying that 3/4 of the people, or 75% of the people, are within 2 standard deviations. Okay, this rule doesn't work for 1, so we're only going -2 to 2. And he said that the people in this range should be 75%. Okay, now if we do the formula again, that would be 3 standard deviations. So 1 over 3 squared, which is 1 minus 1/9, or 8 over 9, which is listed over here, 8/9, which is 89%. So according to Chebyshev, he says that from -3 to 3 standard deviations, -3 to 3 standard deviations, should be 89% rather than what the empirical rule said. Empirical rule, I'll put in blue. Empirical rule does have numbers for 1 to 1, and that was 68. 2 to 2, instead of 75, they say 95. And 3 to 3 was 99.7 versus the 98. So it's just according to what these people have said, is approximate. The Chebyshev versus the empirical rule, they basically, to come up with these percentages, they've looked at data for ever and ever and ever, and they've crunched these numbers, and they've looked at what percent of data actually falls within 1 standard deviation or 2 standard deviations, and they've compared those numbers like this. So one of them says it's 68, 95, and 99.7. One of them says, hey, I don't have a formula for 1 standard deviation, but two standard deviations is 75, 89. We could continue out to 4 standard deviations, but usually it's just between 1 through 3. So it's just a differing opinion in how those numbers are calculated. So IQ scores, again, we're going to do Chebyshev's theorem. And then we're going to save coefficient of variation for tomorrow when I come back. Not tomorrow, because you guys are going to be gone tomorrow. Thursday when everybody's back. So same thing again, but we're going to compare. So X bar is 100, and standard deviation is 15. What can we conclude from Chebyshev's theorem? I'm going to go back. This is kind of a vague question. I don't like that they're not really even asking a question. What can we conclude? I'm going to change that question to say, what percent between, let's say, what did they say before? 70 and 130. Okay, that was the same question that was asked on the back side. We're going to compare it to this one. So we have, for Chebyshev's theorem, still put the mean in the middle, 100. But we put 115 here, same as normal, 130 here, 145 here, okay? 85, 70, and 55. We still put those numbers there like normal. This is +1, 1 standard deviation, 2 standard deviations, 3 standard deviations. This is -1, -2, and -3. There we go. So we're looking between 70 and 130, just like we were doing before. Oh man. Right here, not there. My pen got a little crazy. 70 and 130, we're looking at between those two ranges. Before we said 95%, but Chebyshev's theorem says 75%. So that's what he concludes, is that 75% are living within that category. Now, over time, the empirical rule has been more widely accepted than Chebyshev's theorem. So what we will do most of the time is use the empirical rule when they're asking for this type of information. We will not really use Chebyshev's theorem a whole lot. We'll use the empirical rule for one reason, because it has one standard deviation and Chebyshev's theorem does not. But for two, it is more accurate, they have come to find. So I will give you a laminated copy of the empirical rule at some point, and that will help you to do some of the steps. So what I have done, we're going to save this part for Thursday, Tuesday, whatever day we'll come back, Thursday, and we're gonna continue this last little bit here. But I have posted the homework, so what I want you to do is go through the homework and do as much as you can for all the notes that I've given you. Okay, I will see you on whenever we're back again, Thursday.